Imagine a cosmic monster so vast that our entire solar system could comfortably nestle within its event horizon. A beast so massive that its gravity warps the very fabric of space and time. This isn't a creature from a sci-fi movie, but a real entity lurking in the depths of the universe. TON 618, the largest black hole ever found. In just a moment, we'll dive into the mind-bending scale of this celestial leviathan, comparing it to our solar system and even our galaxy to truly grasp its staggering size. Stick around, because once you wrap your head around the numbers, you'll never look at the cosmos the same way again. The scale of the unimaginable. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This behemoth has a mass of approximately 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 120 astronomical units, AU, with 1 AU being the distance between Earth and the Sun. TON 618's event horizon, the point of no return for anything approaching the black hole, is about 300 AU across. That means you could fit our entire solar system inside the event horizon of TON 618 and still have room to spare. It's a scale that boggles the mind, a true testament to the unimaginable vastness of the universe. The sheer size of TON 618 is not just impressive in terms of our solar system, it's also mind-blowing when compared to our galaxy. The Milky Way, our home galaxy, is a vast spiral galaxy with a diameter of about 100 light-years. A light-year is the distance light travels in 1 year, roughly 5.88 trillion miles. TON 618's gravitational influence extends far beyond its event horizon. The quasar itself is incredibly bright, outshining entire galaxies, and its energy output is a result of the immense amount of matter being drawn into the black hole. This matter forms an accretion disk around the black hole, heating up and emitting vast amounts of radiation. The energy emitted by TON 618 is so intense that it can be observed from billions of light-years away. To further grasp the scale of TON 618, consider this. The black hole at the center of our galaxy, Sagittarius A*, has a mass of about 4 million solar masses. That's a fraction of TON 618's mass. If you were to replace Sagittarius A* with TON 618, the event horizon would extend out to about 130 Australian dollars, engulfing Mercury, Venus, Earth, Mars, the asteroid belt, and even Jupiter. It's a stark reminder of the incredible diversity and scale of black holes in the universe. The sheer size of TON 618 challenges our understanding of the cosmos and underscores the vast, uncharted territories that still await exploration. It's a humbling thought, a glimpse into the true enormity of the universe we inhabit. Black holes, a cosmic enigma. In the vast expanse of the cosmos, TON 618 stands as a testament to the mind-boggling scale of black holes. This supermassive black hole, nestled in the heart of a quasar, boasts a mass approximately 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 122 astronomical units, AU. 1 AU is the distance between the Earth and the Sun, roughly 93 million miles. TON 618's event horizon, the point of no return for any object venturing too close, is about 720 Australian dollars across. That means you could fit our entire solar system inside its event horizon and still have room to spare. It's a cosmic leviathan that defies easy comprehension. The sheer scale of TON 618 doesn't end there. Our Milky Way galaxy, a vast collection of stars, planets, and other celestial bodies, stretches about 100 light-years across. A light-year is the distance light travels in 1 year, roughly 5.88 trillion miles. TON 618's gravitational influence extends far beyond its event horizon, warping spacetime in its vicinity. The quasar it resides in, powered by the accretion disk of superheated materials swirling around the black hole, outshines entire galaxies. It's a beacon of intense energy, a reminder of the violent and dynamic nature of the universe. TON 618's immense mass and size make it a subject of intense study. Scientists are fascinated by its properties and behavior, seeking to understand the extremes of physics it represents. The study of such supermassive black holes provides insights into the formation and evolution of galaxies, the nature of space-time, and the fundamental laws of the universe. It's a humbling reminder of our place in the cosmos, a tiny speck in the grand tapestry of existence. Yet, it's also a testament to human curiosity and ingenuity, our relentless pursuit of knowledge and understanding. Ton 618, a behemoth in the void. Ton 618 is a colossal quasar, a type of active galactic nucleus that harbors one of the most massive black holes ever discovered. This behemoth is estimated to have a mass of 66 billion times that of our Sun, making it a true titan in the cosmos. To put this into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. Ton 618's event horizon, the point of no return around a black hole, is estimated to be about 700 times wider than the orbit of Neptune, the farthest planet in our solar system. This means that TON 618 could engulf our entire solar system with ease, and still have plenty of room to spare. The sheer scale of TON 618 is almost incomprehensible. If we were to compare it to our Milky Way galaxy, which is about 100 light-years in diameter, TON 618's event horizon would still be a significant fraction of that size. To give another example, the distance between the Earth and the nearest star, Proxima Centauri, is about 4.24 light-years. Ton 618's event horizon is so large that it could swallow this distance and still have room for more. The mass of TON 618 is also staggering. It's estimated that the entire Milky Way galaxy has a mass of about 1.5 trillion times that of the Sun. TON 618's black hole alone is about 44 times more massive than the estimated total mass of the Milky Way's central supermassive black hole, Sagittarius A star. Ton 618 is not just massive, it's also incredibly luminous. It's classified as a hyperluminous quasar, meaning it's extremely bright and emits a tremendous amount of energy. This energy comes from the accretion disk, a swirling disk of gas and dust that heats up and emits light as it spirals into the black hole. The light from TON 618 is so intense that it outshines entire galaxies. Despite its distance of about 10.4 billion light-years from Earth, it's still visible to us. This is a testament to its incredible luminosity. The energy output of TON 618 is so high that it's thought to be one of the most powerful objects in the universe. It's a true behemoth in the void, a testament to the incredible scale and power of black holes. Comparing TON 618 to our Sun, TON 618 is a colossal quasar, and at its heart lies a supermassive black hole that defies comprehension. This black hole is so massive that it dwarfs our Sun in a way that's almost impossible to fathom. Our Sun, a mere 864 miles in diameter, is a speck of dust compared to TON 618. The black hole at the center of TON 618 has a diameter of about 400 times the distance between the Earth and the Sun. That's right. The distance between our planet and its life-giving star could fit into the diameter of this black hole over 1,000 times. It's a scale that's almost incomprehensible, a testament to the sheer enormity of the universe. To put it into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is about 1 to 87 light-years across. Ton 618's black hole could engulf our solar system with room to spare. It's not just the size that's staggering, but the mass. Our Sun contains about 99 to 86% of the mass of our entire solar system, which is roughly 2 nonillion. That's a 2 followed by 30 zeros, kilograms. Ton 618's black hole, on the other hand, has a mass of about 66 billion times that of our Sun. That's a number so large it's difficult to wrap our minds around. It's like comparing a single grain of sand to a mountain range. The sheer scale of TON 618 becomes even more apparent when we consider our galaxy. The Milky Way is a vast, sprawling place, stretching about 100 light-years across. Yet, TON 618's black hole is so massive that if it were placed at the center of our galaxy, its event horizon would extend out to engulf many of the stars in the galactic core. It's a humbling thought, a reminder of how small we are in the grand scheme of the universe. The energy output of TON 618 is equally mind-boggling. It's one of the brightest objects in the universe, shining with the power of 1 trillion stars. This is all due to the insatiable appetite of its central black hole, which consumes matter at an astonishing rate, releasing energy in the process. It's a cosmic powerhouse, a beacon of light in the vast darkness of space. The event horizon, a point of no return. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This behemoth has a mass estimated to be 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is about 2 light-years across. TON 618's event horizon, the point of no return where the gravitational pull is so strong that not even light can escape, is about 700 times wider than the orbit of Neptune, the farthest planet in our solar system. This means that TON 618's event horizon alone could engulf our entire solar system with room to spare. It's a scale that's almost incomprehensible, a testament to the sheer immensity of this cosmic giant. The event horizon of TON 618 is not just large, it's a boundary that defines the limits of our understanding. Beyond this point, the laws of physics as we know them break down. Time and space become so warped that they lose their meaning. It's a one-way ticket into the unknown, a gateway to a realm where the very fabric of reality is stretched and twisted beyond recognition. The event horizon is the ultimate point of no return, a cosmic boundary that separates the known from the unknowable. It's a stark reminder of the limits of our knowledge and the vast mysteries that still lie ahead. TON 618's event horizon is not just a theoretical construct. It's a real, physical boundary that can be observed and studied. Astronomers use a variety of techniques to probe the mysteries of this enigmatic object. They study the light emitted by the accretion disk, the swirling maelstrom of gas and dust that surrounds the black hole. They analyze the jets of plasma that shoot out from the poles of the black hole at nearly the speed of light. They even use the gravitational lensing effect, where the immense gravity of the black hole bends and distorts the light from objects behind it. Each of these methods provides a unique window into the nature of TON 618 and its event horizon. Despite our best efforts, the event horizon of TON 618 remains a deeply mysterious and enigmatic object. It's a boundary that challenges our understanding of the universe and pushes the limits of our knowledge. But it's also a source of fascination and inspiration, a reminder of the vast and wondrous cosmos that surrounds us. As we continue to explore and study this cosmic giant, we may one day unlock the secrets of the event horizon and gain a deeper understanding of the nature of black holes and the universe itself. Until then, TON 618 and its event horizon will continue to captivate and inspire us, a testament to the enduring mystery and beauty of the cosmos. TON 618's event horizon, a cosmic abyss. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. At its heart lies an event horizon, a boundary beyond which nothing, not even light, can escape. This cosmic abyss is a staggering 130 billion kilometers in diameter. To put that into perspective, our entire solar system, from the Sun to the orbit of Neptune, spans about 9.1 billion kilometers. So, TON 618's event horizon is so vast that it could engulf our solar system with room to spare. It's a scale that's almost impossible to comprehend, a testament to the mind-boggling sizes and distances that characterize the universe. The mass of the black hole powering TON 618 is estimated to be around 66 billion times that of our Sun. To visualize this, consider that our Sun accounts for about 99.86% of the mass in our solar system. Now, imagine a black hole with a mass 66 billion times greater than that. It's a figure that defies easy comparison. Even the Milky Way, our home galaxy, has a supermassive black hole at its center, Sagittarius A*, which is only about 4 million times the mass of the Sun. TON 618's black hole is, quite literally, in a league of its own. The event horizon of TON 618 is not just a point of no return. It's a region of intense gravitational influence. As matter falls into the black hole, it forms an accretion disk, a swirling maelstrom of gas and dust heated to incredible temperatures. This process releases enormous amounts of energy, making TON 618 one of the brightest objects in the universe. The light from this quasar has traveled billions of light years to reach us, offering a glimpse into the early universe. Despite its distance, the sheer scale of TON 618 makes it a prominent feature in the cosmic landscape. It's a reminder of the universe's vastness and the extraordinary phenomena that lurk within it. The mass of TON 618, a stellar leviathan. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This behemoth is estimated to have a mass of 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. TON 618's event horizon, the point of no return for anything falling into the black hole, is estimated to be about 700 times the distance from the Sun to Pluto. If you were to replace the Sun with TON 618, its event horizon would extend beyond the orbit of Neptune, engulfing the entire Kuiper belt and even approaching the inner edges of the Oort cloud. It's a scale that's almost impossible to comprehend, a true stellar leviathan. The sheer mass of TON 618 is a testament to the extreme conditions that can exist in the universe. To give another example, the Milky Way galaxy, which contains 100-400 billion stars, has a supermassive black hole at its center called Sagittarius A star. This black hole is only about 4 million times the mass of the Sun. That means TON 618 is roughly 500 times more massive than the black hole at the heart of our own galaxy. It's a staggering difference, highlighting the extreme nature of TON 618. The energy output from TON 618 is equally impressive. It's so luminous that it's visible from Earth, despite being about 10.4 billion light-years away. This luminosity is a result of the immense gravitational forces at play, which heat up and accelerate the surrounding gas and dust to incredible speeds, releasing vast amounts of energy in the process. The formation of such a massive black hole is still a topic of ongoing research and debate among astronomers. One leading theory suggests that TON 618 formed from the merger of smaller black holes, a process that could have occurred in the dense environments of the early universe. Another theory proposes that it formed from the direct collapse of a massive gas cloud, bypassing the usual stellar evolution process. Regardless of its origins, the existence of TON 618 provides valuable insights into the early universe and the extreme conditions that can exist within it. It's a reminder of the vast and wondrous nature of the cosmos, and a testament to the power of human curiosity and ingenuity in unraveling its mysteries. TON 618's gravity, a dance with darkness. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This behemoth is estimated to have a mass of 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is about 1 light-year across. TON 618's event horizon, the point of no return for anything falling into the black hole, is estimated to be about 1,300 times wider than the Sun's diameter. If you were to replace the Sun with TON 618's event horizon, it would swallow up the Sun, Mercury, Venus, Earth, Mars, the asteroid belt, and even Jupiter. That's a sphere with a radius of about 1/300 astronomical units, AU, where 1 AU is the average distance between the Earth and the Sun. The gravity of TON 618 is so immense that it warps space-time in its vicinity in a way that is hard to comprehend. Light itself bends around the black hole, an effect known as gravitational lensing. This means that if you were to look at TON 618 from a safe distance, you would see a distorted image of the background universe behind it. The gravity is so strong that even light, traveling at the universe's speed limit, would be bent into a tight orbit around the black hole. This creates a region of space where light can endlessly circle the black hole, a phenomenon known as a photon sphere. For TON 618, the photon sphere would be about 2.5 times the size of its event horizon. The sheer scale of TON 618's gravity also affects the behavior of matter around it. As gas and dust fall into the black hole, they form an accretion disk, a swirling maelstrom of superheated material. This disk can extend for thousands of AU and reach temperatures of millions of degrees. The friction and compression within the disk cause it to emit intense radiation, making TON 618 one of the brightest objects in the universe. Despite its distance of about 10.4 billion light-years from Earth, it is still visible through powerful telescopes. The energy output is so vast that it outshines entire galaxies, making TON 618 a true titan among quasars. The dance of darkness that is TON 618's gravity also has implications for the surrounding galaxy. The black hole's immense gravity can influence the orbits of stars and even the overall structure of the galaxy. It can also trigger the formation of new stars by compressing gas clouds. However, the exact effects are still not fully understood, as TON 618 is so distant and its environment so extreme. Studying TON 618 and other supermassive black holes like it helps astronomers understand the fundamental nature of gravity, the behavior of matter under extreme conditions, and the evolution of galaxies. It's a reminder of the universe's vastness and the mysteries that still await discovery. The accretion disk, a swirling cosmic river. TON 618 is a cosmic behemoth, a quasar that houses a supermassive black hole with a mass estimated to be 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. TON 618's event horizon, the point of no return for any matter or energy, is about 700 times wider than the orbit of Neptune, the farthest planet in our solar system. If you were to replace the Sun with TON 618, its event horizon would extend beyond the orbit of Pluto, engulfing everything in our solar system up to that point. Even our Milky Way galaxy, with its 100-400 billion stars, pales in comparison to the sheer scale of TON 618. The supermassive black hole at the center of our galaxy, Sagittarius A*, is a mere 4 million solar masses, making TON 618 roughly 500 times more massive. Surrounding TON 618 is an accretion disk, a swirling cosmic river of gas, dust, and other matter that is being pulled in by the black hole's immense gravity. This disk is not a calm, serene structure, but rather a violent, chaotic maelstrom. As matter spirals inward, it heats up due to friction and compression, reaching temperatures of millions of degrees. This intense heat causes the accretion disk to glow brightly, emitting vast amounts of radiation across the electromagnetic spectrum. The light from TON 618's accretion disk is so intense that it can be seen from billions of light-years away, making it one of the brightest objects in the universe. The accretion disk of TON 618 is not a static structure. It is dynamic and ever-changing, with matter constantly being fed into it from the surrounding galaxy. As matter falls into the black hole, it releases an enormous amount of energy, primarily in the form of heat and light. This process, known as accretion, is one of the most efficient energy-producing mechanisms in the universe. In fact, the energy released by accretion onto TON 618 is so great that it can outshine entire galaxies. The accretion disk also plays a crucial role in the growth of the black hole. As matter falls into the black hole, it increases its mass, causing it to grow larger and more massive over time. Despite its immense size and brightness, TON 618's accretion disk is a relatively small structure compared to the black hole itself. The accretion disk is only about 100 times wider than the event horizon, meaning that it is a relatively thin structure. However, this thinness is deceptive, as the accretion disk is incredibly dense and massive. The matter within the accretion disk is compressed to such a degree that a single cubic centimeter can weigh as much as a small mountain. This incredible density is a result of the immense gravitational forces at play, which squeeze the matter into a tiny volume. The accretion disk of TON 618 is a testament to the incredible forces and processes that shape our universe, and it offers a glimpse into the extreme environments that exist around supermassive black holes. TON 618's accretion disk, a feast of stars. TON 618 is a colossal quasar, a type of active galactic nucleus that harbors a supermassive black hole at its core. This black hole is not just any ordinary one. It's a behemoth with a mass estimated to be around 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. TON 618's event horizon, the point of no return around a black hole, is estimated to be about 700 times the distance from the Sun to Neptune. That's a sphere so vast that our solar system would fit inside it with room to spare. The Milky Way, our home galaxy, is about 100 light-years across, and TON 618's gravitational influence extends far beyond that. At the heart of TON 618's immense power is its accretion disk, a swirling maelstrom of gas, dust, and even stars being drawn in by the black hole's insatiable gravity. This disk is not a gentle, orderly structure. It's a chaotic, violent place where temperatures can reach millions of degrees, and friction and compression heat the material to extreme temperatures, causing it to emit intense radiation. The accretion disk of TON 618 is so massive that it's visible from Earth, appearing as a bright, luminous object despite being billions of light-years away. The energy output is staggering, with TON 618 shining with the brightness of 140 trillion suns. This is not a steady glow, either. The disk is dynamic, with fluctuations and outbursts as it feeds the black hole. The sheer scale of TON 618's accretion disk is mind-boggling. It's estimated to be several light-years across, making it one of the largest known structures of its kind. To put that into perspective, the distance from the Sun to its closest neighboring star, Proxima Centauri, is about 4.24 light-years. So, TON 618's accretion disk is large enough to span the space between the Sun and several of its nearest stellar neighbors. Within this vast disk, stars are not just passive bystanders. They are torn apart and consumed, their material adding to the disk's tumultuous mix. The gravitational forces are so strong that even stars are stretched and warped, a process known as spaghettification, before being devoured. The accretion disk of TON 618 is a testament to the extreme conditions that can exist in the universe. It's a place where the laws of physics are pushed to their limits, and where the very fabric of space-time is warped and twisted. The disk's immense size and energy output make it a fascinating subject for astronomers, offering a unique opportunity to study the behavior of matter and energy in the most extreme environments. Despite its distance, TON 618's accretion disk is a vivid reminder of the dynamic and often violent nature of the cosmos. It's a feast of stars, a cosmic banquet where the universe's most massive objects come to dine. Quasars, the lighthouses of the universe. In the vast expanse of the cosmos, quasars serve as some of the most luminous beacons, guiding astronomers through the murky waters of the early universe. These celestial powerhouses are not merely stars, but supermassive black holes, often found at the centers of distant galaxies, actively devouring matter and emitting incredible amounts of energy. Among these cosmic lighthouses, TON 618 stands out as a titan, a black hole of such immense proportions that it defies easy comprehension. To put its size into perspective, TON 618 boasts a mass approximately 66 billion times that of our Sun. This means that if our solar system were to be placed within TON 618, the black hole's event horizon alone would stretch beyond the orbit of Neptune, engulfing all the planets in its path. The sheer scale of this black hole is so vast that it challenges our understanding of the universe's structure and formation. The energy emitted by TON 618 is equally staggering. As matter falls into the black hole, it forms an accretion disk, a swirling maelstrom of superheated gas and dust. This process releases an enormous amount of energy, making TON 618 one of the brightest objects in the universe. In fact, its luminosity is so great that it outshines entire galaxies. The light from TON 618 travels billions of light years to reach us, providing a glimpse into the early universe and the conditions that prevailed when galaxies were still forming. This makes quasars like TON 618 invaluable tools for astronomers, offering insights into the cosmos evolution and the nature of black holes. Comparing TON 618 to our own Milky Way galaxy highlights its monumental scale. The Milky Way, with its hundreds of billions of stars, spans about 100 light-years in diameter. Yet, TON 618's event horizon alone is roughly 700 times wider than the distance from the Sun to Neptune. This means that if TON 618 were placed at the center of the Milky Way, its event horizon would extend far beyond the orbit of the outermost stars. The sheer size of this black hole is a testament to the extreme conditions that can exist in the universe, where matter and energy are compressed to unimaginable densities. Understanding quasars like TON 618 not only expands our knowledge of the universe, but also challenges our theoretical models. The existence of such massive black holes so early in the universe's history suggests that black holes can grow rapidly under the right conditions. This has profound implications for our understanding of galaxy formation and the role that supermassive black holes play in shaping the cosmos. As astronomers continue to study these cosmic lighthouses, they uncover more about the fundamental forces and processes that govern the universe, bringing us closer to unraveling the mysteries of existence. TON 618's quasar, a beacon of energy. TON 618's quasar is an astonishing cosmic phenomenon, a beacon of energy that outshines entire galaxies. At its heart lies a supermassive black hole, one of the most massive known, with a mass estimated to be about 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. TON 618's event horizon, the point of no return for any object approaching the black hole, is about 300 times wider than the Sun itself. If you were to replace the Sun with TON 618's black hole, it would extend beyond the orbit of Mars, engulfing Mercury and Venus entirely. The sheer scale is almost incomprehensible, a testament to the universe's grandeur and our place within it. The quasar's luminosity is another mind-boggling aspect. It radiates energy equivalent to trillions of suns, making it one of the brightest objects in the universe. This energy is generated as the black hole devours surrounding matter, a process that heats the accretion disk to incredible temperatures, causing it to emit intense radiation. The light from TON 618's quasar has traveled billions of light years to reach us, a journey that began when the universe was still in its infancy. Despite this vast distance, the quasar's brilliance is still detectable, a beacon piercing the cosmic darkness. TON 618's quasar is not just a static object, it's a dynamic and violent place. The immense gravitational forces at play create powerful jets of plasma that shoot out at nearly the speed of light, perpendicular to the accretion disk. These jets can extend for thousands of light years, interacting with the intergalactic medium and creating complex structures. The energy output is so immense that it can influence the evolution of the entire host galaxy, regulating star formation and galaxy growth. In essence, TON 618's quasar is not just a beacon of energy, it's a cosmic engine, driving the evolution of its surroundings. Studying TON 618's quasar provides valuable insights into the early universe and the growth of supermassive black holes. The sheer scale and energy output challenge our understanding of physics and cosmology, pushing the boundaries of what we know. It's a reminder of the universe's vastness and the mysteries that still await discovery. As we continue to explore, objects like TON 618 serve as guiding stars, illuminating the path to a deeper understanding of the cosmos. The brightness of TON 618, a cosmic spotlight. TON 618 is a colossal quasar, a type of active galactic nucleus that harbors one of the most massive black holes ever discovered. Its brightness is a testament to the immense energy being released as matter falls into the black hole at its center. This quasar shines with the luminosity of 140 trillion suns, making it one of the brightest objects in the known universe. To put this into perspective, our entire Milky Way galaxy, which contains 100-400 billion stars, pales in comparison to the radiant output of TON 618. The sheer scale of its brightness is akin to a single cosmic spotlight illuminating the vastness of space, outshining entire galaxies. The black hole at the heart of TON 618 is estimated to have a mass of 66 billion times that of our Sun. To grasp the enormity of this, consider that our solar system's radius, from the Sun to the farthest reaches of the Oort cloud, is about 1 light-year. The event horizon of TON 618's black hole, the point of no return for any matter falling in, is about 300 times the distance from the Sun to Pluto. This means that the black hole's event horizon alone could engulf our entire solar system, and there would still be plenty of room to spare. The mass of this black hole is so great that it defies easy comprehension. It's like comparing a single grain of sand to a mountain. The brightness of TON 618 is not just a result of its massive black hole, but also the accretion disk surrounding it. This disk is a swirling maelstrom of gas and dust, heated to incredible temperatures as it spirals inward, emitting intense radiation across the electromagnetic spectrum. The energy released is so profound that it ionizes the surrounding interstellar medium, creating a vast nebula of ionized gas that extends far beyond the quasar itself. This ionized gas can be seen as a faint glow, a cosmic halo that further accentuates the brilliance of TON 618. The sheer scale of this phenomenon is akin to a lighthouse beacon that can be seen across the cosmos, guiding astronomers to one of the most extraordinary objects in the universe. Despite its immense distance from Earth, roughly 10.4 billion light-years, TON 618's brightness makes it a standout feature in the night sky. It's a beacon of light that has traveled across the vast expanse of space and time to reach us, offering a glimpse into the early universe. The study of TON 618 provides valuable insights into the growth and evolution of supermassive black holes, as well as the formation of galaxies in the early universe. Its brightness serves as a cosmic spotlight, illuminating the mysteries of the universe and challenging our understanding of the fundamental forces at play. In the grand tapestry of the cosmos, TON 618 stands as a testament to the awe-inspiring scale and complexity of the universe we inhabit. TON 618's luminosity, 8 billion suns. TON 618 is a colossal quasar, a type of active galactic nucleus that boasts a luminosity equivalent to 1 billion suns. This staggering brightness is a direct result of the supermassive black hole at its center, which is one of the most massive ever discovered. The sheer scale of TON 618 is almost incomprehensible. The black hole's event horizon, the point of no return for any matter or energy, spans a distance of approximately 300 astronomical units. To put that into perspective, 1 astronomical unit is the distance between the Earth and the Sun, about 93 million miles. So, TON 618's event horizon is roughly 300 times the distance from the Earth to the Sun. If placed at the center of our solar system, it would engulf the orbits of all the planets, including Neptune, the farthest known planet from the Sun. It would even extend beyond the Kuiper Belt, a region of icy bodies that includes Pluto. The mass of TON 618's black hole is estimated to be around 66 billion times that of our Sun. This is so massive that it challenges our understanding of black hole formation and growth. For comparison, the supermassive black hole at the center of our Milky Way galaxy, known as Sagittarius A*, is only about 4 million times the mass of the Sun. TON 618's black hole is so large that it would take up a significant portion of our galaxy's central bulge if it were placed there. The sheer gravitational pull of such a massive object is mind-boggling. It warps space-time to an extreme degree, causing the incredible luminosity observed as a quasar. The luminosity of TON 618 is not just a result of its size, but also its activity. Quasars are among the brightest objects in the universe, and their light comes from the accretion disk of superheated gas and dust that swirls around the black hole at nearly the speed of light. This disk emits intense radiation across the electromagnetic spectrum, from radio waves to X rays and gamma rays. The energy output is so immense that it can outshine entire galaxies. Despite its distance of about 10.4 billion light-years from Earth, TON 618 is still visible to astronomers, a testament to its extraordinary brightness. This luminosity provides a unique opportunity to study the early universe and the processes that govern the growth of supermassive black holes. Understanding TON 618's luminosity and mass offers insights into the extreme conditions that can exist in the universe. It pushes the boundaries of our knowledge and forces us to reconsider the limits of black hole growth and the mechanisms driving quasar activity. The study of such extreme objects not only expands our understanding of the cosmos, but also highlights the incredible diversity and scale of the universe we inhabit. TON 618 stands as a testament to the awe-inspiring phenomena that await discovery and exploration in the vast expanse of space. The distance to TON 618, a journey through time. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. Nestled in the constellation Canes Venatici, this behemoth is so distant that its light has traveled for approximately 10.4 billion years to reach us. This means we see TON 618 not as it is today, but as it was when the universe was a mere 3 billion years old. The sheer scale of TON 618 is mind-boggling. Its black hole has a mass estimated to be 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is about 1 light-year across. TON 618's event horizon, the point of no return for anything falling into the black hole, is about 300 times the distance from the Sun to Pluto. If you were to replace the Sun with TON 618, its event horizon would extend beyond the orbit of Neptune, engulfing our entire solar system. The journey of light from TON 618 to Earth is a testament to the vastness of the universe. Light travels at approximately 300 kilometers per second, and it takes about 8 minutes to reach Earth from the Sun. In contrast, light from TON 618 takes 10.4 billion years to reach us. This means we are looking back in time, witnessing the universe as it was in its youth. The distance to TON 618 is so great that it is measured in light years, a unit that represents the distance light travels in 1 year. 1 light year is about 9.46 trillion kilometers. So, TON 618 is approximately 10.4 billion light years away, or about 98 for 100,000,000 kilometers away. This distance is so vast that it is difficult to comprehend. To put it into perspective, if you were to travel at the speed of light, it would take you 10.4 billion years to reach TON 618. The sheer scale of TON 618 is not just impressive, it's downright humbling. Our Milky Way galaxy is about 100 light-years across, and it contains an estimated 100-400 billion stars. Yet, TON 618's black hole is so massive that it could swallow our entire galaxy and still have room to spare. The event horizon of TON 618 is about 300 times the distance from the Sun to Pluto. If you were to replace the Sun with TON 618, its event horizon would extend beyond the orbit of Neptune, engulfing our entire solar system. The mass of TON 618's black hole is estimated to be 66 billion times that of our Sun. To put that into perspective, the mass of our Sun is about 330 times that of Earth. So, TON 618's black hole is about 21,780,000 times the mass of Earth. This is a scale that is difficult to fathom, but it is a reminder of the vastness and complexity of the universe. TON 618's location, a remote cosmic outpost. Nestled in the constellation Canes Venatici, TON 618 is a hyperluminous quasar, a type of active galactic nucleus that defies comprehension with its sheer size and luminosity. This cosmic behemoth is located approximately 10.4 billion light-years from Earth, placing it in a remote corner of the universe. To put this distance into perspective, light from TON 618 has been traveling towards us for over 10 billion years, a journey that dwarfs the age of our own solar system, which is a mere 4.6 billion years old. The quasar's host galaxy is so far away that it appears as a faint, smudged point of light in even the most powerful telescopes. The scale of TON 618 is mind-boggling. At its heart lies a supermassive black hole with a mass estimated to be 66 billion times that of our Sun. To grasp this, consider that our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 2 light-years across. TON 618's event horizon, the point of no return for anything drawn into the black hole, is estimated to be about 1/300 times the distance from the Sun to Pluto. If you were to replace the Sun with TON 618, its event horizon would extend far beyond the orbit of Neptune, engulfing our entire planetary system. The black hole's immense gravity warps space-time to such an extent that it bends light around it, creating a gravitational lens that magnifies the light from distant galaxies behind it. Despite its remote location, TON 618 is one of the brightest objects in the universe. It shines with the luminosity of 140 trillion suns, making it visible to astronomers on Earth despite its vast distance. This incredible brightness is due to the accretion disk of superheated gas and dust that swirls around the black hole at nearly the speed of light. As this material spirals inward, it heats up to millions of degrees, emitting intense radiation across the electromagnetic spectrum. The energy output is so immense that it outshines entire galaxies, making TON 618 a beacon in the cosmic dark. The sheer scale of TON 618 challenges our understanding of the universe. It is a testament to the extreme conditions that can exist in the cosmos, where black holes can grow to unimaginable sizes and emit staggering amounts of energy. Studying TON 618 and other hyperluminous quasars provides valuable insights into the early universe, the formation of supermassive black holes, and the evolution of galaxies. It reminds us that, despite our advancements in astronomy, the universe still holds many mysteries waiting to be uncovered. The age of TON 618, a timeless giant. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This behemoth is so large that it defies easy comprehension. To put its size into perspective, the black hole at the heart of TON 618 has a mass estimated to be about 66 billion times that of our Sun. This is so massive that it's difficult to find a suitable comparison within our own solar system. If you were to replace the Sun with TON 618's black hole, its event horizon, the point of no return, would stretch beyond the orbit of Neptune, engulfing our entire solar system. Even the orbit of Pluto, the distant dwarf planet, would be well within the event horizon of this monstrous black hole. The sheer scale of TON 618 is almost incomprehensible. Our Milky Way galaxy, which contains 100-400 billion stars, has a supermassive black hole at its center called Sagittarius A star. This black hole is minuscule in comparison, with a mass of about 4 million times that of the Sun. TON 618's black hole is roughly 500 times more massive than Sagittarius A star. To visualize this, imagine a single grain of sand representing Sagittarius A asterisk and a small boulder representing TON 618's black hole. The difference in mass is staggering, highlighting the extraordinary nature of TON 618. The age of TON 618 is another fascinating aspect of this cosmic giant. Quasars are incredibly luminous objects, and their light has traveled vast distances to reach us. TON 618 is so far away that the light we see from it today left the quasar when the universe was much younger. This means we are seeing TON 618 as it was billions of years ago. Despite its ancient light, TON 618 remains an active and powerful quasar, continuously emitting enormous amounts of energy. This energy output is a testament to the immense mass of its central black hole, which fuels the quasar's brilliance. The discovery and study of TON 618 have provided astronomers with valuable insights into the early universe and the growth of supermassive black holes. Its sheer size and age make it a unique object of study, offering a glimpse into the conditions and processes that shaped the cosmos in its formative years. As we continue to explore the universe, objects like TON 618 serve as crucial pieces in the puzzle of cosmic evolution, helping us understand the origins and development of galaxies, black holes, and the universe itself. TON 618's growth, a cosmic glutton. TON 618 is a colossal quasar, a type of active galactic nucleus, and it harbors one of the most massive black holes ever discovered. This cosmic behemoth is so large that it defies easy comprehension. To put its size into perspective, the black hole at the heart of TON 618 has a mass estimated to be about 66 billion times that of our Sun. That's not a typo, 66 billion solar masses. To visualize this, consider that our entire solar system, from the Sun out to the orbit of Neptune, spans about 5.5 billion miles. TON 618's event horizon, the point of no return for anything falling into it, is about 700 times wider than the orbit of Neptune. In other words, our solar system would fit comfortably inside the event horizon of TON 618's black hole. The growth of TON 618 is a testament to its insatiable appetite. Black holes grow by accreting matter, and TON 618 has been feasting for billions of years. The quasar's immense luminosity, shining with the brightness of 140 trillion suns, is a direct result of this voracious consumption. The accretion disk around TON 618, a swirling maelstrom of gas and dust, is so massive that it could span light years. As matter spirals inward, it heats up to millions of degrees, emitting intense radiation that makes TON 618 one of the brightest objects in the universe. This process is not just a slow, steady meal. It's a cosmic gluttony that has allowed TON 618 to grow to its staggering size. To further grasp the scale of TON 618, consider our Milky Way galaxy. The Milky Way is a vast, barred spiral galaxy containing 100-400 billion stars, and it spans about 100 light-years in diameter. The supermassive black hole at the center of the Milky Way, known as Sagittarius A*, has a mass of about 4 million solar masses. That's a fraction of the mass of TON 618's black hole. If you were to place TON 618 at the center of the Milky Way, its event horizon would extend far beyond the orbit of Neptune, engulfing the Kuiper belt and possibly even the Oort cloud, a distant region of icy objects that marks the outer boundary of our solar system. In short, TON 618 is a cosmic glutton of unimaginable proportions, a testament to the extreme conditions that can exist in the universe. The future of TON 618, a slow fade into darkness. TON 618 is a colossal quasar, a type of active galactic nucleus that harbors a supermassive black hole at its center. This black hole is one of the most massive known, with a mass estimated to be about 66 billion times that of our Sun. To put this into perspective, the entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year in diameter. TON 618's event horizon, the point of no return for any object approaching the black hole, is about 1,300 times wider than the Sun itself. If placed at the center of our solar system, it would swallow everything out to the orbit of Saturn and then some. Even our Milky Way galaxy, with its 100-400 billion stars, would seem modest compared to the scale of TON 618. The sheer size of this black hole is almost incomprehensible, making it a fascinating subject for astronomers and astrophysicists. Despite its immense size and brightness, TON 618 is not immortal. Like all quasars, it is powered by the accretion of matter into its central black hole. This process generates enormous amounts of energy, making the quasar visible across vast cosmic distances. However, this feast of matter is not infinite. Over time, the supply of gas and dust feeding the black hole will diminish. As the fuel runs out, the quasar will gradually fade, becoming less luminous. This process is already underway, as TON 618 is not as bright as it once was. The decline is slow, measured over millions of years, but inevitable. The future of TON 618 is a slow fade into darkness, a process that will take millions, if not billions, of years to complete. The eventual fate of TON 618 is to become a quiet, dormant black hole, no longer feeding on surrounding matter. It will still have its immense mass, but without the accretion disk and the intense radiation that make it a quasar. The surrounding galaxy, if it still exists, will be a normal, perhaps even unremarkable, galaxy. The black hole will continue to exert its gravitational influence, but it will no longer be the dominant feature it is today. The light from TON 618 that we see now left the quasar over 10 billion years ago. By the time the quasar fades completely, the light from that event will have traveled even further, making it invisible to any potential observers in the distant future. The universe is vast and dynamic, and the rise and fall of quasars like TON 618 are part of its ever-changing tapestry. Comparing TON 618 to other supermassive black holes, TON 618 is a behemoth even among supermassive black holes, a class of celestial objects already known for their mind-boggling sizes. To put its scale into perspective, TON 618 has a mass estimated to be about 66 billion times that of our Sun. This is so massive that it's roughly 15.0 times more massive than the black hole at the center of our Milky Way galaxy, Sagittarius A star. The event horizon of TON 618, the point of no return for anything drawn in by its gravity, is estimated to be about 715 times the size of the Sun's radius. If you were to place TON 618 at the center of our solar system, its event horizon would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars entirely within its boundary. The sheer scale of this black hole is almost incomprehensible, making it a true cosmic leviathan. Comparing TON 618 to other supermassive black holes reveals just how extraordinary it is. For instance, the black hole at the heart of the galaxy M87, made famous by the first ever image of a black hole shadow, has a mass of about 6.5 billion solar masses. This is a fraction of TON 618's mass, highlighting the latter's exceptional size. Even the black hole in the galaxy NGC 4889, one of the largest known, has a mass of around 21 billion solar masses, less than a third of TON 618's mass. The sheer volume of TON 618's accretion disk, the swirling material around it, is also staggering. This disk is so large that it would span the distance from the Sun to the orbit of Pluto and beyond, making it one of the most luminous objects in the universe. The energy output from TON 618 is equally impressive. It is classified as a hyperluminous quasars, meaning it emits an enormous amount of light and other radiation as it devours surrounding matter. This energy output is so intense that it can outshine entire galaxies. The light from TON 618 has traveled billions of light years to reach us, providing a glimpse into the early universe. Its brightness and size make it a crucial object of study for astronomers seeking to understand the growth and behavior of supermassive black holes. The sheer scale of TON 618 challenges our understanding of the universe and pushes the boundaries of what we know about these enigmatic objects. TON 618 versus Sagittarius A*, a David and Goliath story. In the vast cosmos, black holes come in all sizes, but few can match the sheer enormity of TON 618. Nestled in the constellation Canes Venatici, this cosmic behemoth is a quasar, a type of active galactic nucleus. And it's not just any black hole, it's the largest one ever found. To put its size into perspective, TON 618's Schwarzschild radius, the boundary within which nothing can escape its gravitational pull, is about 1,389 times the size of the Sun. That means if you were to replace our Sun with TON 618, it would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, the asteroid belt, and the gas giants in its wake. The sheer scale is mind-boggling, a testament to the universe's capacity for extremes. Now, let's bring Sagittarius A* into the picture, the supermassive black hole at the center of our Milky Way galaxy. It's a heavyweight in its own right, with a mass about 4.3 million times that of the Sun. But compared to TON 618, it's a mere featherweight. TON 618 tips the scales at a staggering 66 billion solar masses. To visualize this, imagine our solar system as a grain of sand. Now, Imagine a boulder the size of a small mountain. That's the kind of difference we're talking about. Sagittarius A asterisk is to TON 618 what a David is to a Goliath, a stark reminder of the cosmic scale at play. The sheer mass of TON 618 isn't just a number, it's a force that shapes its environment. The accretion disk around TON 618, the swirling mass of gas and dust being pulled in by its gravity, is so hot that it emits intense radiation, making TON 618 one of the brightest objects in the universe. In contrast, Sagittarius A asterisk is relatively quiet, a sleeping giant compared to the raging beast that is TON 618. The energy output from TON 618 is so immense that it's visible from billions of light years away, a beacon of cosmic power that dwarfs the humble glow of our own galaxy's core. Yet, despite its size, TON 618 is not the most massive black hole in the universe. There are others, like Phoenix A, which is estimated to be even larger. But TON 618's sheer scale and brightness make it a standout, a testament to the universe's capacity for extremes. It's a humbling reminder of our place in the cosmos, a tiny speck in the grand tapestry of the universe. And as we continue to explore and understand these cosmic giants, we gain a deeper appreciation for the wonders and mysteries that lie beyond our home planet. The role of TON 618 in galaxy formation. TON 618 is a colossal quasar, a type of active galactic nucleus that harbors a supermassive black hole at its core. This black hole is one of the most massive known, with a mass estimated to be about 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is about 1 light-year across. TON 618's event horizon, the point of no return for anything falling into the black hole, is about 300 times the distance from the Sun to Pluto. That's a sphere so vast that our solar system would be a mere speck within it. The Milky Way's supermassive black hole, Sagittarius A asterisk, is a lightweight in comparison, with a mass of only about 4 million suns. The sheer scale of TON 618's black hole has profound implications for galaxy formation. Black holes of this size are thought to play a crucial role in shaping the galaxies around them. They can regulate star formation by heating and expelling gas, which would otherwise collapse to form new stars. This process, known as feedback, can halt the runaway growth of galaxies, preventing them from becoming too massive. TON 618's immense gravity and energy output would have a significant impact on its host galaxy, influencing its structure and evolution. The quasar's powerful jets and radiation could sweep away interstellar gas, creating voids and triggering star formation at the edges of these bubbles. This interplay between the black hole and its galaxy is a dynamic process that shapes the cosmos on the largest scales. TON 618's black hole is also a testament to the rapid growth that can occur in the early universe. Such massive black holes are thought to form from the merger of smaller black holes or from the collapse of extremely massive stars in the early universe. The existence of TON 618 suggests that these processes can occur quickly, allowing black holes to reach enormous sizes in a relatively short time. This rapid growth can have cascading effects on galaxy formation, as the energy released by the black hole can influence the evolution of its host galaxy and its neighbors. The study of TON 618 and other supermassive black holes provides valuable insights into the complex interplay between black holes and galaxies, shedding light on the fundamental processes that shape our universe. TON 618's influence, a cosmic puppeteer. TON 618, a colossal quasar, harbors a supermassive black hole that defies comprehension. This behemoth tips the scales at a staggering 66 billion times the mass of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 1 light-year across. TON 618's event horizon, the point of no return for any object venturing too close, is estimated to be about 700 times the distance from the Sun to Pluto. If you were to replace the Sun with TON 618, its event horizon would extend beyond the orbit of Jupiter, engulfing our entire planetary system. The sheer scale is almost impossible to fathom, yet it's a reality that underscores the cosmic puppeteer's immense influence. This cosmic giant exerts a gravitational pull so strong that it warps the fabric of space-time itself. Light, the fastest thing in the universe, struggles to escape its grasp. The quasar's brightness is a testament to this power, outshining entire galaxies. TUN 618's influence doesn't stop at its event horizon. It extends far into the cosmos, shaping the destiny of stars, gas, and dust in its vicinity. This black hole is not just a passive observer. It's an active participant in the cosmic dance, pulling strings and orchestrating the movements of celestial bodies. Consider the accretion disk, a swirling maelstrom of gas and dust that feeds the black hole. Heated to incredible temperatures, it emits intense radiation, making TUN 618 one of the brightest objects in the universe. This radiation, in turn, influences the surrounding interstellar medium, triggering star formation or quenching it entirely. The black hole's jets, streams of high-energy particles, can extend for thousands of light years, punching holes in galaxies and regulating their evolution. In this way, TUN 618 acts as a cosmic puppeteer, pulling the strings of its galactic theater. The sheer scale of TUN 618's influence is a humbling reminder of the universe's vastness and complexity. It's a stark contrast to our human experience, where the largest structures we build are dwarfed by even the smallest cosmic entities. Yet, understanding these cosmic puppeteers helps us piece together the grand tapestry of the universe, revealing the intricate connections that bind it all together. From the smallest atom to the largest black hole, everything is interconnected, and TUN 618 is a testament to that cosmic web. The mystery of TUN 618's origin. TUN 618 is a colossal quasar, a type of active galactic nucleus that harbors a supermassive black hole at its center. This black hole is so enormous that it defies conventional understanding. To put its size into perspective, the black hole's event horizon, the point of no return, spans approximately 400 times the distance from Earth to Pluto. If placed at the center of our solar system, its event horizon would extend far beyond the orbit of Neptune, engulfing our entire planetary system. The mass of TUN 618's black hole is estimated to be around 66 billion times that of our Sun. This is so massive that it challenges the known mechanisms of black hole growth and formation. The sheer scale of TUN 618's black hole raises intriguing questions about its origin. Current theories suggest that black holes grow by accreting matter and merging with other black holes. However, the time required for a black hole to grow to such a size is significantly longer than the age of the universe. This discrepancy suggests that there might be alternative or additional mechanisms at play. One hypothesis involves the direct collapse of massive gas clouds in the early universe, bypassing the usual star formation process. Another possibility is that TUN 618's black hole formed from the merger of multiple smaller black holes in a dense environment, such as a globular cluster or the center of a galaxy. The environment in which TUN 618 resides also offers clues about its origin. Quasars are typically found in the centers of galaxies, and TUN 618 is no exception. It is located in a massive elliptical galaxy, which is a type of galaxy that is often the result of galactic mergers. This suggests that TUN 618's black hole may have grown through a combination of accretion and mergers. The galaxy's massive size and the presence of other supermassive black holes in similar environments support this idea. However, the exact processes that led to the formation of TUN 618's black hole remain a mystery, and further research is needed to fully understand its origin. The study of TUN 618 and other supermassive black holes is crucial for understanding the universe's evolution. These objects play a significant role in shaping their host galaxies, influencing star formation and galaxy evolution. By studying TUN 618, astronomers hope to gain insights into the early universe, the formation of the first black holes, and the processes that drive their growth. The mystery of TUN 618's origin serves as a reminder of how much we still have to learn about the cosmos and the fundamental forces that govern it. TUN 618, a window into the early universe. TUN 618 is a colossal quasar, a type of active galactic nucleus that offers a unique glimpse into the early universe. Its sheer size is almost incomprehensible. The black hole at its center has a mass estimated to be 66 billion times that of our Sun. To put that into perspective, our entire solar system, from the Sun to the farthest reaches of the Oort cloud, spans about 122 astronomical units, AU. 1 AU is the distance from the Earth to the Sun, roughly 93 million miles. TUN 618's event horizon, the point of no return for anything falling into the black hole, is about 700 Australian dollars across. That means you could fit our entire solar system inside the event horizon of TUN 618 and still have room to spare. It's a scale that boggles the mind, a testament to the extreme conditions that existed in the early universe. The light we see from TUN 618 has traveled an astonishing 10.4 billion years to reach us. This means we're seeing it as it was when the universe was just a fraction of its current age. Quasars like TUN 618 are powered by the accretion of matter into supermassive black holes. The energy released is so immense that it outshines entire galaxies. TUN 618 is one of the brightest objects in the universe, with a luminosity of 4 trillion times that of our Sun. This brightness allows astronomers to study the early universe in detail, providing insights into the formation and evolution of galaxies. Studying TUN 618 helps us understand the conditions of the early universe. The existence of such a massive black hole so early in the universe's history challenges our understanding of black hole growth and galaxy formation. It suggests that black holes can grow extremely rapidly under the right conditions. The accretion disk around TUN 618, the swirling mass of gas and dust falling into the black hole, is a hot, turbulent place. Temperatures can reach millions of degrees, and the material is compressed to extreme densities. This environment is a crucible for the creation of heavy elements, which are then dispersed throughout the universe. TUN 618 also provides a unique laboratory for studying the physics of black holes. The extreme conditions near the event horizon allow scientists to test theories of general relativity and quantum mechanics. Observations of TUN 618 have confirmed predictions made by these theories, such as the existence of an accretion disk and the emission of jets of high-energy particles. These jets, which can extend for thousands of light years, are a common feature of quasars and provide a way to study the interaction between black holes and their host galaxies. By studying TUN 618, astronomers hope to unlock the secrets of the early universe and gain a deeper understanding of the fundamental laws of physics. As we wrap up our journey into the cosmic abyss, let's take a moment to truly grasp the enormity of TUN 618. This behemoth is so large that our entire solar system, from the Sun to the farthest reaches of the Oort cloud, could comfortably fit inside it. In fact, TUN 618 is so massive that it's nearly 0 times more massive than our Sun. To put that into perspective, if our Sun were a single grain of sand, TUN 618 would be a small boulder. And its event horizon, the point of no return, is so vast that it could swallow our entire solar system whole. It's a cosmic leviathan that defies comprehension, a testament to the incredible diversity and scale of the universe we live in. So what do you think? Does the sheer scale of TUN 618 leave you in awe? Or does it make you feel incredibly small? Either way, we hope this video has given you a new appreciation for the vastness of space and the incredible objects that call it home. If you're hungry for more cosmic wonders, be sure to like, share, and subscribe for our next adventure into the unknown. Until then, keep looking up, and remember that the universe is full of incredible secrets, just waiting to be discovered.